Now, before we start writing equations of lines, the first thing we need to do is talk about slope. And hopefully you guys have seen this before, but just in case, let's do a refresher on it. Slope is actually the ratio of the change in y compared to the change in x. So a much easier way of looking at that is rise over run. Because, and look at the way that their example is here. Let's say that we had a point here and a point here. We could talk about this as to move from this first point to the second point, we would have to rise up and then we would have to run over. So that would be the change in the y's would be the rise, the up and down, and the change in the x would be the run, or the moving to the right there. Now, notice in every single one of these lines that they have drawn out for you, our slope here is 6 over 7, 6 over 10, 6 over 4, the ratio of the rise compared to the run. Also, I want you to notice that each one of these is a positive number. We're going to look at that again here in just a minute. All right, now if you have a picture drawn out, you can actually look at the rise compared to the run in each one of these. But if sometimes you're only going to have points. So the formal definition says if you've got 2 points, this x1, y1 means the x and the y value from your first point. This x2, y2 means the x and the y value from your second point. So if we have 2 different points here, then here is our formula that we use to find the slope. We subtract the y's, that's going to give us the rise, the difference in the y's. And then we subtract the x's, that's going to give us the run, or the difference in the x's. Now, it does not matter which one of these points you call the first one and which one you call the second one, but they have to be kept together. The x and the y from the second point have to stay together, and the x and the y point from the first point have to stay together, and then they have to be put into the equation in the proper place. So as we're doing some of these problems later on, it might be a good idea to go ahead and write out the equation and then plug in your numbers where they belong. Let's look at some examples here. Here we have 4 different graphs, and let's look at the rise to the run in each one of these. If I were going to, and I always like to look left to right, it's really important to keep that in mind also. To get from this point to this point, we would have to rise up, 3 units, and we would have to run over 2 units. So if our slope is the ratio of rise to run, we would rise 3 and run 2 to get to that next point. That's the slope of that line. Now let's look at this one. Here again we have these 2 points, and I want to look left to right always. So if I were going to move from this point to this point to find the slope, I would have to rise. This time I'm actually going down, though. The rise is in the negative direction. So we're going down, what is that, 7 units? We count how many units we're going down. So our rise is actually -7, and our run here in this case would be 2 units. So our slope now is -7 over 2. Now I want you to notice that as we look at these lines left to right, if it's going up, the slope is positive. If it's going down, the slope is negative. That will always be true. Now let's look at a couple of these special cases here. Let's look at the slope here. The rise to get from this point to this point is 0, and the run would be 3 units. So 0 divided by 3 is 0. So our slope of horizontal lines is always 0. For vertical lines, to get from, let's say, this top point to this bottom point, we would have to rise, 5 units, or to go from this one to this one, either way, but we run nothing. When we divide by 0, we always call it undefined. So all vertical lines have an undefined slope.